On June 29, 1908, the Tunguska region of Siberia was a pristine wilderness. The nomadic Evenki tribes hunted caribou amidst 2 million acres of pine forests, untouched by industrialization. Temperatures hovered at -5 degrees Celsius despite summer, with permafrost locking ancient secrets beneath the soil. This tranquility would last just 24 more hours before history's most violent cosmic event. At 7:17 a.m. on June 30th, eyewitnesses reported a second sun blazing across the sky. The object, later calculated to be 50 to 80 meters wide, moved at 15 kilometers per second, outshining Venus by 1,000x. Reindeer herders 60 kilometers away described deafening thunderclaps as it descended at a shallow 30-35 degree angle, its plasma trail visible across 700 kilometers. The 10-15 megaton airburst occurred at 5 to 10 kilometers altitude, releasing energy equivalent to 600 Hiroshima bombs. Shockwaves circled Earth twice, while seismic sensors 4,000 kilometers away detected tremors. The explosion flattened 80 million trees across 2,050 square kilometers in a symmetrical butterfly pattern, a phenomenon never observed in nuclear tests. Within 30 kilometers of the epicenter, 2,000 square kilometers of forest was reduced to matchsticks. Thermal radiation ignited fires 15 kilometers away, while electromagnetic pulses disrupted telegraph systems 500 kilometers distant. Evenki tents were hurled through the air, and nomadic families reported third-degree burns despite being 60 kilometers away. The blast registered on barographs worldwide. Soviet mineralogist Leonid Kulik reached the site 19 years later, expecting to find a meteorite crater. Instead, he discovered the 8-kilometer-wide telegraph pole forest, millions of standing dead trees stripped of branches. Using 1920s equipment, Kulik mapped the butterfly-shaped devastation, but found no impact fragments, puzzling scientists worldwide. Kulik's 1927 theory proposed a 100,000-ton stony meteorite exploding mid-air. Modern simulations suggest a porous asteroid would fragment at 45 kilometers altitude, while an iron-rich one would reach the ground. Neither matches Tunguska's evidence. 1960s researchers found microspherules suggesting a comet's icy nucleus vaporizing completely, but no known comet produces such energy. In 1946, sci-fi writer Alexander Kazantsev first suggested an alien nuclear spacecraft explosion. Anomalies fuel this theory. No debris was ever found. Trees at the epicenter remained standing, suggesting an overhead energy burst, and 1958 studies revealed genetic mutations in plants. Witnesses described the object changing course, impossible for natural bodies. 2007, Italian researchers claimed Lake Cecco, 8 kilometers NW of epicenter, is an impact crater, but sediment dating disproves this. 2013 mineral analysis found nanodiamonds suggesting 10,000 degrees Celsius temperatures. LiDAR scans reveal subtle ground depressions, possibly from shock waves, while radiation anomalies match no known meteorite composition. Mainstream science favors a rare airburst meteor explanation, noting similar but smaller events like 2013 Chelyabinsk. Critics highlight inconsistencies. The object's trajectory changes, absence of water or chemical traces from comets, and radiation patterns resembling theoretical antimatter annihilation. Both sides agree such an event over a city would kill millions. 115 years later, Tunguska remains Earth's largest recorded cosmic impact, with no definitive answer. The site became a pilgrimage destination for ufologists and scientists alike. Modern planetary defense programs use it to model catastrophe scenarios. Whether natural or otherwise, the event reminds us of humanity's vulnerability to forces beyond our understanding or control.